So this is graphing quadratic functions. Let's get started. Let me change my color. All right, so bear with me here, and let's just get through all these steps. So my first step is to factor and solve. First thing I'm going to do is I'm going to factor out that negative and realize that my graph is going to look something like this, right? It's going to be frowning. So when I factor out a negative, I get x squared minus 4x plus 3. I'm solving it, so I'm going to set it equal to 0. This one I can factor straight out. I don't need an x box because x times x is squared, and 3 only factors into 1 and 3, right? Those are the only factors, so that's a no-brainer. But how could I make this and this make negative 4x? They're both negative. So my solutions to this quadratic function are x equals 1 and x equals 3. So I'm going to go over here to 1. See how the scale is different on this graph? Okay. 1 and 3. I'll let you guys get your papers all settled. All right, so if I know those are my zeros, can't I also see that my axis of symmetry is going to be right here? Yeah. So my whole point today of finding the axis of symmetry is that if I know my zeros, I can see it. So let's practice it when we can see it, and then tomorrow when we can't see it, then we'll know we're doing it correctly because we already practiced. Does that make sense? Because tomorrow we're going to have a graph something like this. Are there any zeros for me to figure out where my axis of symmetry is? No. No, so we're just going to have to find it. All right, so B says, find the axis of symmetry and vertex. The axis of symmetry is x equals negative b over 2a. Okay, check this out, side note. X equals negative b plus or minus the square root, b squared minus 4ac, all over 2a. What is that? What does that do for us? Gets us x. X, what is that? It gives us our zeros. If we can't factor, and we can't do this, we can't complete the square, our last resort is this. Well, check this out. This part of the quadratic formula is called the discriminant. The discriminant tells us, so this whole thing right here tells us where our zeros are. This part right here tells us that there's 2 of them. Remember that? The discriminant tells us whether there's 1 solution, 2 solutions, or no solution. Look what's left. Which I think is pretty cool. The axis of symmetry is left over. So this whole thing tells me this and this. It tells me whether or not there are roots, and then it tells me where's the middle of them. I think that's pretty cool. I know I'm a math teacher, but that's pretty cool. That whole thing can do all 3 of those things for us. It tells us everything we need to know about the graph. All right, so moving on. So if you ever forget this, you just have to remember what's on the outside of that discriminant. Negative b over 2a. Okay? No. So negative b over 2a is, I'm going to go back up to my original equation just so I don't make any mistakes. You can use this one in here as well, but I just think it's safer to go back to that original equation. So negative b is negative 4 over 2a, which is negative 1. You would get the same thing if you used this in here. So negative 4 over negative 2 is positive 2, which is in fact what we got, right? All right, now that I have that, let's put this over here. So x equals 2. That's half of it. That's my axis of symmetry. Now let's find the vertex. I know the vertex lies on that line right there, right? Somewhere where x is 2 and y is, we don't know. How would I find out? Plug it back in. The function of 2 equals negative 2 squared, I'm using that original equation right there, plus 4 times 2 minus 3. 2 squared is 4, so this is negative 4 plus 8 minus 3. Negative 4 and positive 8 is positive 4 and minus 3 is 1. So my vertex is 2, 1. Looks like it's negative. Isn't it a negative graph? It is. C. I found A, I found B, C. Find the y-intercept. How do I find the y-intercept? What is always 0 when you're on the y-intercept? X. F of 0 equals, aren't all of these going to zero out? Plus 4 times 0 minus 3. All you're left with is negative 3, which is right here. Does that make sense?
Yeah.
If it's symmetrical, wouldn't I also have another solution right there? D, graph. I'm going to graph it. That wasn't too bad. E, minimum or maximum. I think of video games, right? Video games are a bunch of functions. When Mario jumps up, there's a function where he can only jump that high. So this is the maximum that Mario can jump. This is a maximum function. This would be minimum, right? If you were to fall down into a valley, that's the lowest he could go. So E would be, this is a maximum point at my vertex. F is domain and range. My domain, no matter how far I go in this direction on my X, I'm always going to have a solution. Infinite solution. In this direction, I'm always going to have a solution. So that's all real numbers. And my range, going in this direction, always having a solution. What about this way? Stop right there. There are no more solutions to this graph above 1. So y, such that y has to be, oops, not greater than, but less than or equal to 1. Question? Yes. Step C, find the y-intercept. That one's here. Okay, so remember on the test we did, if you want to find the intercept, you plug in, if I want to find the x-intercept, I plug in y equals 0. If I want to find the y-intercept, I plug in x equals 0. So I just made x equal to 0 and plugged it right into this equation right here. Everywhere I saw an x, I made it 0. Let me say it a different way. If I say my y-intercept is 1, what's x? 0. If I said, I'm sorry, negative 1. If I said my y-intercept is 1.5, what's x? No matter where I'm at on this line, isn't x always 0? So if I want to find out where the graph crosses this line, I always just make x 0. Does that make sense? Because this is my function. No matter what my solutions are on this line right here, this graph, if I were to substitute in 2, I'm going to get 1. If I were to substitute in 3, I'd get 0. If I were to substitute in 4, anytime I put something into this function, I'm going to get an output of y, and it's going to be on this line. So all I have to do is put in 0. Uh-oh. Okay, so any more questions on this one? Hopefully, Jesus, it'll become easier and easier to see. All right? I know it's a lot right now to take in. So I'm going to pass out your homework. You guys can copy this example. I'm going to do another one. No, not on there. I'm going to give you your homework, and it's the exact, this is number 1 on your homework. Okay? So I just did number 1. Then we're going to do number 5 together, and we're going to do number 4 together, and then you're going to be able to just keep going and doing it on your own. Okay? All right, so let's do number 5 together. So we'll start with factoring. I want to factor this out. Because I have my leading coefficient is 1, I don't need an x box on this one, right? Because I know that this first factor right here splits into 2. It splits into x times x, correct? And 5, the only way to factor 5 is 5 and 1. So how would I make 5x and 1x make negative 6x? They're both negative. All right, let's solve for that. That means x equals 5 and x equals 1. So here's where x equals 5 and here's where x equals 1. B, find the vertex and the axis of symmetry. I can already see my axis of symmetry should be at 3. So let's just make sure. X equals negative b over 2a. B is negative 6. Here's my a, here's my b, here's my c. So negative b is negative negative 6 over 2 times 1, which is 3. So I'm correct. Now I need to find my vertex somewhere on that line. So I already know that x is 3. I need to find what y is. So Jesus, that's the same thing as when I'm finding the y-intercept. When I'm finding the y-intercept, isn't x 0? See that? So this time I'm going to plug in 3, the function of 3. Yep, always, because it's got to be on that line, right? So I'm going to plug in 3, and I get 3 squared minus 6 times 3 plus 5 is 9 minus 18 plus 5. 9 minus 18 is negative 9. Negative 9 plus 5 is negative 4. So when x is 3, y is negative 4, which is down here. Are you guys getting it now?
Yeah.
I did that. See how it takes a couple to see what we're doing? C, find the y-intercept. So this time I'm going to make x what? 0. Same thing as I did with this one for the line of symmetry, but now I've got a different line, right? It's the y-intercept line. So I need to put in 0 for x, and I get 5. So when x is 0, y is 5. I don't have a 5 on here, but if I did, it'd be way up here, right? Would that make sense for this graph? Yes, it would. Okay, I'm going to go over here and draw it because it's hard to do it on my screen right there. Last time I did it, it looked like an absolute value function. All right, so I drew my graph. D, let's draw it. E is maximum or minimum. Is this a minimum vertex or maximum? Minimum. Think of Mario. When Mario jumps, that's the maximum he can jump. That's the way I remember it. And the other one's minimum. So max, min. F is my domain and range. What is my domain? All real numbers. There's constantly solutions in the positive x and in the negative x. My range, however, stops at -4. So y, such that y has to be greater than or equal to -4. Is that starting to make more sense?
Yes.
Okay, good. So like I said, that's really abstract, right? Okay, any questions on this one? You guys ready to go? All right, let's do one more. Let's do number 4. So start number 4 on your own, and then we'll go piece by piece. Okay, so I pulled out a 2 first, so I could factor this nice and easily. Then I found that x must be -3 and -1, so I plotted -3 and -1. Then I drew in my axis of symmetry, and I'm in the process of checking it. So negative b, if this is a, and this is b, and this is c, then b is 8 over 2 times 2. -8 over 4 is negative 2. That's where I'm at, negative 2, so we're good. Now, I'm going to find my vertex. I know that x must be 2. Let's figure out what y is. So I need my function of negative 2. 2 times negative 2 squared plus 8 times negative 2 plus 6. Let me extend this a little bit. And I get 2 times 4 is 8 minus 16 plus 6. 8 minus 16 is negative 8. Negative 8 plus 6 is negative 2. So negative 2, negative 2. Does that make sense? C, find my y-intercept. I want to find out where my graph is at 0 question mark. 0 question mark. So what would I plug in for x? 0. And I would get 6. You guys catching on to that trick yet?
Yeah.
Good. We'll talk about it in a second. All right, 6 is right here. That means I must have another plot right here. Go ahead and graph that. Not the best graph. That's okay. E. Is this minimum or maximum? Minimum. What's my domain? All real numbers. And what's my range? Such that y is or equal to negative 2. You guys got this now, huh? Questions on any of this? Off and running? Are you still copying? Okay, I'll wait a second before we go to the next. All right, so what did you learn today? Graphing, quadratic. Name the components to consider when graphing a quadratic. What do you have to consider? What? Okay, you're looking for your zeros. What else do you need to consider? Yes? GCS? Well, that's the steps. What we're considering are zeros. We consider, think of when you're graphing, what does it look like? You consider the zeros, you consider the axis of symmetry, you consider the vertex, right? And you also consider the y-intercept when you're graphing. All right, the person next to you is absent. How would you explain how to find the axis of symmetry? What? Negative b over 2a, or there's a nice little trick, right? Not trick, really, but take out the discriminant. Remember I showed you that? If you forget that it's negative b over 2a, just think of the quadratic formula without the discriminant. All right, on your assignment sheet, I noticed that in a quadratic equation, the constant is always what? It's always y what? This graph right here is always what, Mitchell? It's always the y-intercept. You just said y. Well, but specifically, it's always the y-intercept. All right, good job, guys.